custom term can help you finish paying off your mortgage in a time frame that's best for you.
Excuse me.
And by taking years off the loan, you'll potentially save dollars in interest over the life of your mortgage, helping you take control and achieve your financial goals. Despite what mortgage rates are historic, this means
Hi, Emmy.
may be your best opportunity to refinance to a lower rate.
Hello.
How are ya?
On your mortgage.
Good.
Now could be a great time to take some positive financial steps with a cash out refinance from Quicken Loans.
Hi, ladies. You guys are early today.
Yeah.
Hi. Make sure you guys head over to Google Classroom and fill out today's check-in.
I'm filling it out right now. Hi, Miss.
Hi, good afternoon. Oh, look at that dog.
He likes being in the stroller.
That's cute. My dog is injured.
Maria has ice cream.
Poor boy.
I'll get in. So, Friday. Monday chicken. What's the riddle?
Oh, I forgot the riddle. Let me pull that up.
Wait, today's because we have riddles and Fridays, Wednesdays, Mondays. I didn't know the answers from the riddle.
He's laying on the couch, injured. All right, let's see today's riddle.
What's the riddle? What's the riddle for today?
Today's a challenge.
Orange. You can see my dog. He likes to be in this little blanket snuggled up in the stroller. The riddle was where is today supposed to be?
All right, here's the riddle. Imagine you are in a room filled with water. There are no windows or doors. How do you get out? Don't say the answer. Remember, you have to go to Google Classroom and put it inside your daily check-in. This is our challenge for today.
Our challenge?
Yeah, because I think it's kind of hard to answer the correct answer.
I think I already know the answer.
Heard this before. Yeah.
Whoa.
I heard this riddle before.
You have?
Hi, Miss Roslyn. This is my mom.
Wait, what's the riddle?
Hi.
I don't know.
It says, imagine
Is
you
this
are in a
the
room
riddle?
filled with water. There are no windows or doors. How? do you get out?
I don't know.
Well, that's why it's a riddle.
Oh, I accidentally raised my hand.
You got to figure it out. Marilyn, that's not correct. Try again.
Miss Breslin, this is big brain, okay?
This is what?
This is gonna be a big brainer, okay?
Okay. Hi, Jason.
Hi, how are you?
I'm good. How are you?
Good.
Eric, that is correct. You get like every single one I do correct. Do you Google the answer or something? I want you to use your brain.
Miss, guess what?
What?
My baby brother's gonna be born in the hospital. My mom's at.
Oh, she went to the hospital today?
Yeah.
So I thought he was going to be born in 2 weeks.
That's what I thought, but he's gonna come early.
Oh, congratulations. That's exciting.
Wait, did someone already see the answer?
No, we're not saying
Miss
the
Bradley.
answer.
Are we texting it to you?
Well, no, you're supposed to go over to today's check-in on Google Classroom Monday, Wednesday. Fill that out.
There's a question.
What about if you don't know it?
Oh, then put down, I'm not sure what the answer is. Or just
I have a
guess.
question. I have a question, Bradley.
I might have an answer. Ask your question. What is it?
Do you have it in the riddle? Do you have anything with you or anything?
Nope. That's all the information you get there.
Okay. That's all I needed to know.
Yep. That's it.
Wait. Do you like
Welcome to all of you that are just joining. I have displayed here
riddle?
our daily riddle. It's a challenge today because it's Friday. So don't forget to go to Google Classroom and turn in your daily check-in.
Mean.
Isaac, I don't ever see you turn that in. Jason, make sure you go to Google Classroom and turn that in.
Hello.
That sounded like Dante.
What's up, Dante?
Mark, you never go and turn that in either. Make sure you go and turn that in.
Listen to Miss Breslin.
What, are you talking to me?
Yes,
Yeah.
Mark. Dante, make sure you go over to Google Classroom and turn in that daily check-in. That's how you get your attendance for class. If you don't fill it out, even if I talk to you, it doesn't count. So you need to make sure you're being responsible in filling that out.
I finished it.
That ain't where anybody can see or hear you.
What? You can't see the riddle?
No, it doesn't. It doesn't show me. It just says
I
you have
can't
to share
see.
your
I
screen.
can see the riddle.
You know what I don't like?
can see
Some people just show their face for like 10 minutes and then they just did.
Wait, what is my screen show?
It just shows black.
Imagine you are tell breathe
Okay, goodbye.
screen.
I see everything. I
I see everything.
middle of the day. Imagine you are in a room filled with water. There are no windows or doors. How would you get out?
Do you see it now, Katie?
Yeah.
Yes, mates.
Oh, all right. Cool beans. All right, we have a lot to do today, so we are getting started right at 2:05. Fill out your daily check-in.
I bet.
I'm actually doing it on my tablet so that I can fill out my.
Wonderful. Fantastic.
Famous president.
Huh?
Ready to get muted?
No, everybody get ready to get muted.
So remember, you just fill it out, but you do not turn in on attendance. Veronica, that is not the correct answer. Edgar C, that is the correct answer.
Los con pollo.
Maria, that is not the correct answer.
How do you know?
Esmeralda, that is the correct answer.
Am I
I feel like
correct?
some people are Googling it.
We probably heard before.
I feel
'cause
like
I've
they
heard
are
all of
too.
this.
So don't spoil the fun and Google it. That's cheating.
I don't Google my riddles.
Use your big brain. It's big brain time.
Big brain.
I don't Google riddle. I do it.
Wait.
It's 2:05.
Oh, it's 2:05, so I'm going to mute you all.
Nah, fam, please don't.
Yeah. All right. So it's time for us to get started. I'm going to stop sharing my screen for a minute and say good afternoon, my amazing scientists. All right, so we are actually starting a new scope today. And so I put out this document for you today, which I'm gonna need you to go and fill out right now. A couple of people have already filled it out, like Dante and Emmy. One person from Miss Jolly's class did. I don't remember who that person was. But anyways, I'm gonna show you what document I'm talking about. So let me get rid of the riddle of the day, and we will go over to Google Classroom, and we don't want it under attendance. Oops, I don't know what just happened there. Oh, I don't know. Anyways, we're gonna go to Friday. What do you know about light? And then go ahead and click on this, and I'll read these for you right now. And I'll read the directions for you as well. However, you need to go there yourself right now so you could follow along, because you have to answer the question down below. This is an easy 2 points for you to get in class today. It says light reflection. You and your 3 brothers, James, Nathan, and Tyreek, are watching TV at night. Suddenly the lights go out and you are surrounded in darkness. You can't see a thing. Your brothers start to argue about what to do. James says, I think we should find a flashlight. When there is light, the light shines on the surface of objects and reflects back to our eyes. The light enters our eyes and we can see the objects. Tyreek says, you're wrong, James. We don't need a flashlight to see. In a minute, the light inside of our eyes will help us see. And Nathan says, you are both wrong. All objects make their own light. We just have to wait for the light to start coming out of the objects like it does out of our TV. Then we will be able to see things in the room. So you have to choose which brother you agree with most and be ready to explain your reasoning. So I put a sentence starter down here for you. I agree with, and you're going to put in there either James, Tyreek, or Nathan, and because, and you're going to explain why you agree with that brother. So I'm going to go ahead and set a timer on my phone for 2 minutes. So you have 2 minutes to get that done in class. If you don't, you have to do it outside of class. My timer's going. So everybody should be in Google Classroom filling this out. I need to know your thoughts and what you think you know about light. If you already filled this out, you can go to Google Classroom. I left you a note. Some of you, I asked you a question to ask you something further about what you said. That's a good question, Arlene. She said, do you just put their name? No, you have to put their name and you have to justify your thinking. So you have to explain why you think that person is correct. So you would put right here, I agree with, I don't know, who's this? Nathan. I agree with Nathan because I think blah, 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 blah. Why do you agree with what that brother said? So you need to justify your thinking. And then when you finish, you're going to hit submit or turn in. I don't know which one it says. And then come back to class. And then we're going to play a quick game after this. We have about 30 seconds left. So make sure you're thinking about that and finishing up your idea. Yes, after you have filled out your thoughts and you've put a brother and explained your thinking, you turn it in. All right, time is up. That was my alarm. So I need you to finish up your sentence that you're working on and hit submit. And then type in the chat if you hit submit or not. Put yes or no. I have 32 people in here, so I should see 32 responses. Yes, yes. I just got here. Not yet. Uh-oh. This is how we fall behind, guys. I give you time in class to do something, and then we're not using our time wisely, and we're not completing it. And then we end up forgetting about it, and then we get behind, and then it just snowballs, and we get behind more and more and more. So you need to make sure that you're utilizing the time that I give you. I did it. Yes, yes, yes. DD. I don't know what that means. I am almost done. Yes. What are we doing? David, you need to go to Google Classroom. Oh, actually, David, you already did this, so you're good. This was the question that I posted when we, before we even came to class, and I asked you to answer this question before you come to class. So I know that I only got about 6 people total who answered the question, so I wanted to give a little bit of time. All right, so I did not receive 30 yeses or nos. I received about 10. So I'm still waiting for that yes or no. Done. Ha ha. Okay. Yes, 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 yes. I said yes. Okay. Well, if you said yes one time, that's all you need to say it. Thanks. All right. So I'm going to move on. We're going to play a quick game of a scavenger hunt. So get ready. You're going to have to leave, and you're going to have to go and get your items. So the first one says, find a red marker, colored pencil, or crayon. You have 1 minute to leave and go and find this. And your time has started. Good luck. Ooh, Emmy's already back with a red marker. Nice. Isaac, go find your red marker, colored pencil, or crayon. Esmeralda found a red crayon. Noreni has a red colored pencil. Jason, that looks like a regular pencil. You got to have a red one. All right, time's up. Hold it up for the camera. I got one. Let's see if you found it. Nice. If you didn't, you can put a thumbs down with a sad face. Ooh. All right. Oh, we got a new person. All right, up next, we have, find something that emits light. That means something that gives off light, something that lights up. I have a cell phone. That gives off light. Oh, Aixa has like these fancy lights in her room. Cool. Let's see what else I have around here. Oh, snap. Light bulb, hey-o. 20 seconds left. Nice, Jason. All right, time's up. Let's see you hold it up for the camera. Let me turn my light on. Ooh. Nice. Somebody like actually brought a lamp. Cool. All right. Objects down. Remember, don't put these objects away. We will be using them today for science class. Next up, moving on. Find a blue marker, colored pencil, or crayon. 1 minute. Naomi, are you going to go look for the stuff? Oh. 20 seconds. Oh, Jason found one. Nice. Mark has one. Isaac has one. 10 seconds. Time's up. Go ahead and hold up that blue marker for the camera. If you didn't find one, you could put the thumbs down and the sad face. Tobias, I thought I saw you holding one. What happened? All right, next up we have find something with waves. Ooh. I've got nothing. Oh no. Oh, look at that. Let's steal this. I found a painting that has waves in it. Hey-o. Oh, I see Eric making waves. Arlene grabbed a bottle of water. Time's up. Hold up your waves for the camera. Dante is literally doing the wave. Awesome. We have a couple more. Let's see. Find a yellow and orange marker, colored pencil, or crayon. Found a yellow. Found an orange. Woo! On a roll. It could be a pen too, I guess. Oh, time's up. All right, so hold them up for the camera so we can see it. I see some people with crayons, colored pencils, markers. Dante has this cool looking pen. I don't know what that is. Maybe it's that lightsaber he's been throwing up. Aixa has crayons and colored pencils. All right, I think we have one more. Find a green marker or colored pencil. I'm only going to cut this down to 30 seconds this time. Oh, maybe not. Oh, no. What just happened? Oh, man. Now you get even more. Oh, all sorts of shades of green. Got mine. Oh, I'm going to pause that because there is one more. So let's see your green. There you go. Woo! For those of you that just came, we've so far found something red, orange, yellow, green, and blue to color with, either a marker or a crayon or a colored pencil. We found something that emits light and something with a wave. And our last one is find a white piece of paper or anything to on. Got it. Time's up. All right, so there's my piece of paper. Hold it up for the camera. If you didn't find one, how come? Hopefully we all have paper at our house. All right, so those are all the supplies that we are going to need today for our class. And so the first thing I wanted to do is make a connection with you. So what have we been studying in class since we've been doing virtual learning? Can somebody raise their hand and tell us? I see people are typing it in the chat. Anybody want to raise their hand and share? I see quite a few people. How about all? What have we been learning about in virtual learning, Alejandro?
Waves.
What kind of waves? We'll push you even further.
Wavelengths.
That is a characteristic of the wave. I want to know what kind of waves though. There's two kinds of waves that we've been learning about. One starts with a T and one starts with an L. Does that help your brain? You want to call on a friend? There's some people that have their hands up. Choose somebody and I'll call on them.
Dante.
Dante. What kind of waves have we been learning about, Dante?
Longitudinal and transversal.
Yes, and transverse waves. Yes, absolutely. Thank you. I know longitudinal is kind of hard to say, but so what's the difference between those two? Can anybody explain that to me? Why are there two different sound waves? Or sorry, I didn't mean to say that. Why are there two different waves? Oh gosh. I'm going to call on Esmeralda. Esmeralda. Oh, I didn't hear.
My hand.
You're cutting out. Okay, I'll go to Eric. I don't know what happened there. Eric?
The difference between both of the waves is one of them is like waves in water and one of them is sound waves.
Yeah, so I want to dive a little bit deeper into that. So one of them actually travels through mediums, so through something like waves, they travel through water or something. And then our sound waves, those just travel through particles in the air. And so there's a difference, and there's also a difference in the way they look. So one of them actually looks like a wave. I have an example right here that goes kind of up and down, if you will. And then the other wave goes back and forth. And so that's the difference between those two waves. But we're going to start off our new scope talking about light and light waves. So I actually wanted to make that connection with you, that the reason why we're going over this is because light is actually energy and it travels in waves. And so I have a video to show you to tell you more about that. So let me pull that up. Oh, hold on. I hear somebody whispering. If you are not muted, can you please mute yourself? That was strange. All right, so this is, actually, I'm not sure that I'm sharing the sound with you. No, I'm not. All right, let's try that again.
Here's a question for you. If you shine a light on a coin that's hanging in midair, what do you think its shadow will look like? Do you think its shadow would have a bright spot of light right in the middle of it? Because it would. It might seem counterintuitive, and 19th century physicists thought so too when they tried this experiment. But that little spot in the middle of the coin's shadow helps prove one of the most important discoveries ever made in physics. Light is a wave. In the 17th and 18th centuries, most physicists thought that light was a particle because it often behaved like one. But over the years, some scientists began to think that it might actually be a wave. They did experiments to test this idea, and slowly evidence started to build. We now know that light is both a particle and a wave, a strange sounding concept that we'll explore more later on. But the point is, light is a wave, and we know this because waves behave in very specific and sometimes weird ways. One of the most important reasons that light acts the way it does is known as Huygens' principle. Christian Huygens was a
I'm going to pause this because somebody just said in the chat she talks really fast. Yes, she does. So it's important that we're listening and that we're trying to keep up. So yeah, because she's a very quick, fast talker. Let's see.
19th century Dutch physicist who believed light acted as a wave. He came up with a way to predict how a wave will spread out, and we still use his method today. Huygens' principle says that you can predict a wave's position in the future by analysing its current position. All you have to do is think of each point on the wave as a source of its own tinier wave. See, Huygens knew that when you multiply the velocity of something by the amount of time it's travelled, you can figure out how far it went. And he figured that this would also be true for each individual point on a wave. Let's say you have a wave that's travelling 10 centimetres per second, and you want to know what the wave will look like after 2 seconds. To use Huygens' principle, you first draw a bunch of little...
So we could use a simple mathematical equation to figure that out. So if a wave traveled 10 millimeters, I think she said, I don't know what she said, per second, and we wanted to figure out what it was for 2 seconds, we would just simply multiply that and figure that out. So 2 times 10, which would be 20. But this is going to describe how they came up with that formula and how we know that that's true. This is a little more complex than what we need to know in 4th grade. And this is actually a 5th grade standard, but I just wanted to make this connection with you guys about waves. And this was the best video I could find to do that.
Point along a wave. Then you draw a half circle around each point in front of the wave with a radius equal to the wave's velocity multiplied by time, so 20 centimeters. Each of those little half circles is called a wavelet. Finally, you draw a curve that's tangent to each wavelet, meaning that it touches each half circle at exactly 1 point. That line shows the location of the wave after 2 seconds. So a 2-dimensional wave traveling through empty space will look pretty simple. It's basically an expanding circle. But things get a little more complicated when a wave hits an obstacle. For example, let's apply Huygens' principle to a wave that moves past the edge of a flat object. When the wave hits the obstacle, part of it gets blocked, but the part that isn't blocked keeps moving past the edge, and it follows Huygens' principle, forming wavelets. The wavelets from the part of the wave near the edge will curve behind the edge. And when you draw a line to connect all the wavelets, you end up with a line that bends around the edge. In the same way, when a wave moves through a slit that's roughly the same width as its wavelength, it travels past the slit in a circular curve that spreads outward. When waves are reshaped by obstacles, that's called diffraction, and it's very different from what a stream of particles would do. For example, if you rolled a bunch of marbles straight through a doorway, you'd expect them all to hit the far wall directly opposite the doorway. They wouldn't hit the wall in places to the right or to the left of the door. But when waves diffract, they often spread outward behind obstacles. Diffraction is one of the reasons there's a bright
Okay, so I just wanted to go over, that was a lot of information. So what she's saying is when there's something in the way of the wave, that it's actually going to stop right there, but it's going to push through whatever opening it has, and then it's going to spread out, just like you can see right here in this image. Versus if you just roll the ball, like she said, gave the example of a marble through that crack, it would just go straight through. But the wave is not going to do that. It's going to diffract, is what she said.
Spot in the middle of the shadow when you shine a light on a round object. The other reason is interference. In our lesson on travelling waves, we describe what happens when waves run into each other. They interfere in one of 2 ways. Waves interfere constructively when the crests of both waves end up in the same spot, and so do their troughs. The waves essentially combine into one wave that has a larger amplitude, with higher crests and lower troughs than either of the 2 waves did before. But waves interfere destructively when one wave's crest runs into the other wave's trough, and vice versa. In that case, the combined wave has a lower amplitude than either of the waves did before. With perfectly destructive interference, the waves actually disappear completely. They flatten out. Together, diffraction and interference help explain the results of the famous double-slit experiment conducted by English physicist Thomas Young in 1801. Young covered a window so that only a very narrow stream of sunlight passed through a slit into the room. Then he positioned a plate with 2 more tiny slits cut into it, spaced very close together, so that the single beam of sunlight passed through them. Finally, he placed a screen behind the slits. If light were just a stream of particles, you'd expect to see 2 bright lines on the screen behind the 2 slits. But that's not what Young saw. His screen had many lines on it. There was a bright line in the middle, then more bright lines above and below it. This pattern is called a diffraction pattern, and it comes from the diffraction and interference of light waves. Light waves interfere constructively when they're lined up exactly right. For example, to form that line on the screen between the 2 slits, the waves from each slit travel exactly the same distance. So they line up, interfere constructively, which increases their amplitude to create a bright spot. But in other places on the screen, there's a difference between the distances traveled by each wave. This is called the path difference. So light waves will interfere either constructively or destructively, depending on the size of this path difference. When the waves are an exact number of wavelengths apart, the crests and troughs will line up, creating constructive interference and a bright line. But when the waves are shifted by exactly half a wavelength, or by 1.5 wavelengths, or 2.5, and so on, light rays will interfere destructively. By using trigonometry, you can calculate the path difference in a slit experiment. It's equal to the distance between the centre of each slit, d.
You don't need to know all that.
The line in the centre will be the most intense, and the further the lines get from the centre, the less intense, and therefore the less bright they'll be. Like other waves, light also has a frequency and wavelength. These determine whether light is visible, and if so, what colour it is. Light with a higher frequency and therefore a shorter wavelength is on the bluer side of the spectrum.
So I'm going to pause it right there. So she's going into frequency and wavelength, which is what we should be familiar with. And she just said on the spectrum of colors that if it has a higher frequency and shorter wavelengths, then it is going to be down towards the blues. And I've actually made a drawing of this, which you will too. So do you see that frequency right there? Thumb up if you can see my frequency. Thank you, Esmeralda. I'm not sure if Mark can. He doesn't have a thumb up. Alejandro did. Arlene does. Naomi does. Mercy does. Awesome. All right, so let's see what she says. Or why don't you predict, what do you think the wavelength is going to look like at the opposite end of the spectrum when it's red? Somebody please raise their hand and tell me what you think. Remember, there's no right or wrong answer because you're giving me your opinion and what you think. And if we are incorrect, it's okay. That's part of learning. So if the wavelengths are short and frequent on the blue end of the spectrum, what do you think it is on the opposite end, which would be where the red and the orange is? I see Isaac with his hand up in the chat. Let me try to find him on here. I don't know what Isaac that is. Isaac Areola. Okay. Isaac, what do you think?
Dang it, I just forgot the question.
The question is, what do you think the wavelength will look like on the opposite end of the spectrum where it's red and orange and yellow? You're making a prediction.
What I think it will look like, wait, when it's turned to that side?
So she just explained that the frequency is a high frequency with short wavelengths when it's blue. What do you think it would be when it's red on the opposite side?
I think it would be a low frequency.
A low frequency? And what do you think the wavelength would look like?
The wavelength will be farther apart.
Okay. Let's see if you are correct. Thank you, Isaac. Let's see what she says.
Light with a lower frequency and a longer wavelength is on the redder side of the spectrum. White light, light from sunlight, is actually...
Yay! So she just said that red light has a lower frequency and a longer wavelength. And I actually have a picture of that right here for you as well. So at the end of this video, we're just going to make a picture like this, just so that way we can kind of line this up in our head, what they're talking about with wavelengths and frequency as it refers to light on the spectrum.
All of the different colors of light combined. When white light passes through the two slits in the experiment, they interfere in a way that allows you to see this rainbow of colors in the lines on the screen. But the double slit experiment isn't the only situation where light creates a diffraction pattern. Diffraction will happen when light passes through a single slit too, producing a pattern that looks like a series of lines that get dimmer the further you get from the center. The light will be the brightest on the part of the screen that's opposite the middle of the slit. That bright line is created by the rays that go straight through the slit, perpendicular to the plate. They have a path difference of 0. But to reach the other points on the screen, different rays of light travel different distances, depending on their angle going through the slit. And again, whether the light interferes constructively or destructively depends on how the rays line up. For a single slit, the path difference is between the light coming from the very top of the slit and the light coming from the very bottom of the slit. The path difference is equal to the width of the slit, d, times the sine of the angle between the point on the screen and a line straight from the slit to the screen. If the path difference is one wavelength long, then the path difference between the light from the... So how do diffraction and interference create the phenomenon we see in the shadow of the coin? Diffraction makes the light waves curve around the coin's edges. When these diffractive waves run into each other, they interfere. The places where the waves...
All right, so that's the answer to her question at the very beginning. If there was a coin that she was pointing a light at, she said, would you see a light in the center? And the answer was yes, which is kind of strange. And so the reason because of that is because the light is being diffracted right here around that coin. But just like we learned in this video, those waves actually start to bend around it and then meet back up again. And so because they're doing that, you're able to see that light in the center, which is pretty interesting, I think.
Interfere destructively become shadows. That's what makes those little ripples spreading outward from the circular shadow. But the places where the waves interfere constructively become bright spots. That's why there's a bright spot right in the middle of the coin's shadow. At that point, the waves of light that diffracted around the edges of the coin have all traveled the same distance. So the crests of the different light waves combine, and so do the troughs, forming one wave with a higher amplitude and a bright spot. Today you learned about the wave theory of light.
So that's a little bit more in depth than what we're going to get into in 4th grade, but I just wanted to make that connection between waves, that it's not just sound waves, we also have light waves, and we have more than just mechanical waves. So I'm going to go ahead and close this down, and then we are going to conduct a mini experiment right now. And so I need to make sure that everybody can see me. Yes, right? Okay, so I'm going to stop my video for a second. And then I'm going to go somewhere. Let's see. Oh, this isn't going to work because of the computer. Oh, man. Let me see what I could do. All right. Can you see me now? Yeah, right. That's a good idea, Arlene. I don't know how to do that though. Man, I like planned this experiment out and was like super excited about it. And now I won't be able to do that. Oh, I might have found it. All right, that's like as good as it's going to get for me. So, can you see me now? You can go ahead and write in the chat if you can see me or not. So I'm actually standing in a dark closet, and you probably cannot see me. Oh, somebody said they can see my glasses, so let me take those off. So, well, actually I can't take those off because then I can't see. So let me cancel that. Why do you think in a dark closet that you cannot see me? Why would you think that? There's something that we need in order for you to see. Yeah, Katie said there's no light. So if I were to do this, can you see me now? That's my flashlight that I brought with me into the closet. So in order for us to see something, we have to have a light And then that light gets reflected to our eyeballs in order for us to see that. Does that make sense? I'm gonna get out of the closet because my dog's freaking out and he doesn't know where I went. And he's running around. Crazy. I'm right here, Bailey. It's okay. All right, so I have another video for you guys. I actually can't see my screen now that I turned it down so low. I have another video for you guys that just kind of talks about that, about us having to have a light source in order to reflect those waves to our eyeballs, so that way our brain can interpret what it is and then we can see it, okay? So this is our last video and it's only 3 minutes, so it's super short. And then we will be done with class today. Let's see, what is all this? I don't know what just happened there. It shut down my screen sharing, I don't know why. All right, let me close riddle of the day. Close that. And then here is my video.
How do we see things around us? You would probably say it's the eyes that help us to see the objects around us. But will our eyes be able to see these objects in dark? No, we need light to see things. Without light, we cannot see the objects. But where is this light coming from? This light is coming from this source, which is a fluorescent bulb. You see that this bulb is emitting its own light. The objects which emit their own light are called luminous objects. Can you give me any other examples? Incandescent light bulb, the sun.
Oh, hey lady. I was gonna ask that question. All right, so what are some things that emit their own light? So what do I even mean by that when I say that? What are some things that emit their own light? So when we're thinking about this, we really need to think about energy. Somebody said the moon. I would agree. Although I feel like that's a reflection. So maybe I don't really agree. The sun, that is correct. Somebody said a phone. I'm assuming you're meaning a cell phone, and that actually does not emit its own light. That is coming from a battery, so it is transferred energy. It is being transferred from that chemical energy into light energy. So it does not create its own light, but the sun does. Somebody said fire. Light bulb. A light bulb, again, is a transfer of energy. There's one more thing that nobody has mentioned. The sky does not emit light. It's the sun that does that. Otherwise, the sky does not emit light. Nope, not a phone, because that's a transfer of energy. So we have sun, fire. What else could it be? Isaac has his hand up. Isaac?
Luminescence also emits its own light.
I have to think about that. I'm not sure about that because I think that's a transfer of energy and
Bioluminescence?
chemical reaction from what they eat that allows it to transfer to light.
Yeah, probably. Well.
Thanks, Isaac. Eric? Eric?
Stars.
What?
Stars.
Yes, the stars. Nice job.
Can you give me any other examples? Incandescent light bulb, the sun, the stars are also luminous objects. What about objects such as this table and chair? Do they emit their own light? No, these objects do not emit their own light. Such objects are called non-luminous. Almost everything around us is non-luminous. Objects made up of wood, plastic, cotton, metal are all non-luminous. What about the moon and the planets? They are also non-luminous. But if the moon is non-luminous, then how come we're able to see it at night? The answer to this is reflection of light. The reason we're able to see any non-luminous objects around us is because of the reflection of light. Reflection of light can simply be referred to as change in direction of light or bouncing of light from some surface. Just like the ball bounces from the ground, light reflects off from a smooth surface. Let me try to explain this in a simple way. The light from the source strikes the object and bounces off from its surface. And when this light reaches our eyes, we see that object. And this is how we see non-luminous objects. When the object is kept in front of the mirror, its image is formed in it. But will we be able to see the image in the dark? No, we won't. So the formation of the image is also due to reflection of light. Let this object be our human body, so at the same time, we are looking at the image. First.
So is the human body luminous? What do you think? Thumbs up for yes, thumbs down for no. Because we can see it reflecting in the mirror. So is the human body luminous? I see some mixed reviews here. I see some people who are not sure, some people with thumbs down, some people with thumbs up. Let's see what she's
Tell me, is our body a luminous or a non-luminous object? Well, it's non-luminous. Human body cannot emit its own light. So the light from the source is first incident on the human body. It gets reflected from it, and this reflected light strikes the mirror. This light is further reflected from the surface of the mirror and reaches our eyes.
So when there's a mirror involved and there's a reflection of light, it's more than just that V shape that she showed before. So if you can see here, there's like a little triangle. So it's coming from the light source.
This is how we're able to see our image.
And then eyes.
Now, obviously, this is not the exact picture of the happenings. I just wanted to give you the intuitive feeling into how this happens. There are a lot of subtleties involved which we will learn in our higher grades.
All right. So that's all I have for you today. This is just our introduction into our next scope. I'm going to stop sharing my screen. There we go. And so hopefully we have a better understanding now. And so I'm just going to go back to the first question that I pulled up, which who did you think was right? Was it James? Was it Tyreek? Or was it Nathan? Remember, James thought that you needed a flashlight in order to see things. And Tyreek thought that light just shoots out of your eyes and you can see things. And Nathan thought that objects just illuminate on their own and provide their own light. And so he just wanted you to wait for that TV to light up on its own, which actually it seems like that would happen, but it doesn't. That is a transfer of energy. And you have to have that electricity that is transferring that into either light or sound or whatever it is that you're getting from that television. So that is a transfer of energy. So all of these are connected, going back to Project Lead the Way and going back to our transfer of energy unit. So who do you think was right? James, Tyreek, or Nathan? You can go ahead and type to me in the chat and let me know if your thinking changed. Maybe you thought in the beginning Tyreek or Nathan or James was right, and now maybe you think somebody else is correct. There's a cleanup song. So I have a lot of people typing James, 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 James. James, 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 James. All right, so it looks like the consensus is, oh, somebody said LeBron James. That was not an option, but good call there. James was the correct choice. So if you did that, kiss your brain, nice job. And if you changed your thinking and now you think that it is James, go ahead and give yourself a kiss on the brain for that too, because that is called learning, my friends. So, somebody said James from Team Rocket on Pokemon. That's hilarious. So, yeah, James is correct. We actually need some source of light in order to reflect that image into our eyeball so we can see. All right. So this is what I need. I'm giving you some homework tonight and over the weekend. I actually gave this homework to you about 3 weeks ago. I know Jason already has this that I'm going to ask, but I need you to try to find a shoebox or any kind of box that has a lid or a box that you can close that doesn't let any light inside. Okay, that is your homework. Super easy, not hard homework. You're welcome. So does anybody have any questions before we leave? Arlene has a question. Yes, Arlene?
Do you put anything inside the box or no?
Yeah, we are going to. So if you want to bring some sort of plastic figurine, if you don't have something like that, ooh, Ike's already has a box. If you don't have something like that, we're going to make one out of paper, okay? So yeah, we're going to stick objects in the box. We're actually going to make something for our science experiment called a shadow box, which is going to help us with light. So if you're interested in what a shadow box is, or you want to get a head start on that, you can Google up shadow box and kind of get some ideas. I made one when I was in college and was like, ooh, I hope I get to teach this one day. It's so cool. And I've been a 4th grade teacher for 5 years. So fortunately for me, I get to make shadow boxes every year. Woo! Good question, Arlene. Thank you. Mark has a question.
Are we going to answer the riddle?
Oh, that is a good question. We could answer the riddle. Did we answer the riddle to Wednesday? I don't think we did. The riddle on Wednesday was, what gets wetter and wetter as it dries? You know the answer to that, Mark? No?
And no.
Okay. Anybody know the answer to that? I know Arlene does. I told her. Marilyn, what do you think the answer to Wednesday's riddle was?
A towel?
A towel. That is correct. Nice job. All right. And so today's riddle was, imagine that you were in a house. I don't remember the rest. Or no, it says, imagine you were in a room filling with water and there are no windows or doors. How do you get out? So what do you think is the answer to that riddle? Some of you already got it correct, and I told you that. Let's see. I know Eric already knows the answer. I'm not going to call on him. I want to see if anybody else has an idea. Somebody said, drink the water. Whoa. Somebody said, get a boat. Someone said a brick wall, call 911. You guys are funny. Let's see. I will call on Emmy here. Emmy, what do you think the answer is?
I think you get a bucket and put it over your head.
She said, get a bucket and put it over your head. That is actually not the answer to this. Somebody said, get a straw. Somebody said, go downstairs. Mark, what do you think the answer is?
I was going to say a straw.
Nope, it's not a straw. Any other guesses? Esmeralda?
Nothing. You do nothing because you're imagining it.
Yes, that is true. You do nothing. Stop imagining. You're just imagining a house. So stop doing it. Nice job, Esmeralda. All right, guys, it is 3 o'clock. I hope you have a fantastic weekend. Make sure you try to get caught up on your work. I'm glad you're here. You matter. I love you. Be safe and have
It
a
was imagine.
bye.
Imagine was the word.
Don't forget to go to specials. It's going to be a beautiful weekend. Enjoy.